is the first episode in the equals MC squared algebra for the summer series.
There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hi, I'm Pie Guy Pepin.
And I'm Chemical Charlie.
And this is equals MC squared. So here we have y equals ax squared plus bx plus c.
Okay, and that's a quadratic equation.
Yeah.
And we've programmed it on Excel. So we have values of a, b, and c. Right now, a, b,
They're
and c
all
are
zero.
0. And we've calculated y at various values of x, as you can see here.
Negative 10 to 10.
All right, so we're only plotting it from 5 to 5, minus 5, but that's fine. So let's, of course, right now y equals 0, and you can see that y is 0 everywhere. So, Pie Guy Pepin, what do you think will happen if I make this
now,
3?
So now if we make this 3, then it'll be 3 everywhere. See?
Okay. The
ball moved up.
And if I make it minus 3?
There'll be minus 3 everywhere. You just did number 3. That's a number value. Makes these all number values. Okay, so now negative 3 makes it 3 everywhere. Let's take out this.
All right, now let's go back to 0, and let's make x equal to, b equal to 1. And so we're just saying y equals x. So now we have a straight line. What's the slope?
It's 1.
Okay.
Wait, no. Yeah.
1.
1.
And now if we make the slope negative 1, what happens?
Now it's going the opposite way.
Okay. And now let's bring it back to 1. But let's make the c 1 as well. You can see we have a straight line, and it goes through the y-axis at x equal to 1. That's the intercept. All right. All right. Now you could see that this line has no curvature, but the slope is 1. Let's make the slope 2, b equal 2.
Okay. Yeah. Well, let's get into the curvature part.
All right. So
we never had a value for a.
So let's keep a. Let's keep everything 0 but a.
Okay. So.
Which shall I make a?
Let's just start with 1.
All right, and now?
And now we get this curve.
What's it called?
A
parabola. Parabola.
Parabola.
Okay, and
okay, so it's curving because negative 5 squared is 25. 5 squared is 25.
Okay, so it's symmetric about the y-axis.
Yeah.
All right, now let's make it minus 1. See what happens. What do you think will happen?
It'll switch the curvature to this way.
Right. It curves the opposite way. All right, now let's go back to 1. And it curves up. And let's make the c, instead of 1, 0, let's make it 2. And now it has an intercept of 2. All right? Yeah. But it's still symmetric. Now let's put some
b into it.
Some b into it, and I'm going to put a 1 in the b.
So now we've made it uneven.
Yeah, we made it non-symmetrical, and it goes up on the right side, on the positive side, and down on the left side. But if I make it minus 1, what will happen?
Then it'll go up on this side and down on the other side.
Okay.
So why does this happen?
Okay, when you make it plus 1, you're adding a term that's going up like that. And when you make it minus 1, you're adding a term that goes that way. So let's make it back to plus 1.
Now
Suppose we make it 10. Now the linear part's going to dominate, and
it looks more like a straight line.
If we make it 100,
And then you probably won't even notice that it was curved. Look.
but it has a slight curvature.
It still has a curve.
All right.
You just can't see it.
And if we make a little more curvature to it by making this 3, you see a little more curvature.
Yeah. Well,
make it 5, a little more curvature.
Make it 500.
And now the curvature is really very apparent.
Yeah.
And the nice thing about this version of Excel, you can get it so that it always adjusts the range so that you see the whole curve. All right, let's go back to 1, 1, and 1. Okay. And you can see, by the way, that this particular one, the curve never crosses the y equals 0 axis, the x axis. It's always above, so it doesn't have any values that equal 0. In other words, there's no roots to this equation, and no real roots. There would be imaginary roots. We'll get into that in a later episode. But if I make this minus 4, let's say, now it does cross the axis, the y equals 0 axis, the x-axis if you want, here and here. There are 2 roots, all right? And we can find those 2 roots by using the quadratic equation or something like that. All right, okay. Anything else we want to say, Pi Guy?
Yeah, that's it.
On red and zinc, zinc, rhodium, chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.